Get started with section 3.3, applications of systems of linear equations. Let's take a look at the very first problem. It says a rectangular soccer field has a perimeter of 360 yards. Its length is 20 yards more than its width. What are the soccer field's dimensions? All right, so generally when we're doing applications, I follow 4 steps. The first step is to define variables. You don't just want to come up with, just throw numbers all over the place. You want to know what the letters represent and then come up with equations based on those letters. Second step is that we set up equations. Third step is that we solve, and then you could always check your answer at the end. So this is what we're going to be doing today. I'll just give you a chance to copy that down, and then we'll go ahead and get started with this. All right, so taking a look, problem number 1, it says a rectangular soccer field has a perimeter of 360 yards. Might be a good idea to draw that out. There's a rectangle. We know the perimeter is 360. I'll put that in the middle. And we know that a rectangle has a length and it has a width. Its length is 20 yards more than its width. So we saw this problem on the last type of exam. And if the length is means equals 20 yards more than, that's 20 plus the W, or W plus 20. What are the soccer field's dimensions? Well, now that we have our variables, we know that the perimeter is equal to 2 times the length plus 2 times the width. The perimeter would be 360. We know that L is equal to W plus 20. And the width is just the width. That's how we defined our variables. So just finishing this up, we get 360 is equal to 2W plus 40 plus 2W. So we just distribute that. $360 would be 4W plus 40. And then if we want to solve for W, we could subtract 40 on both sides. We get 320 is equal to 4W. And if you divide by 4, you'd get that the width is 80. If the width is 80 and you add 20 to that, you'd get the length is equal to 100. All right, so defining the variables were really helpful. We could always check our answers. So if we do 80 times 2, that's 160. 100 times 2 is 200. 160 plus 200 is 360. That's one down. I think we have like 5 or 6 more to go. I just want to focus on this today. Okay, let's make this a little bit bigger so we could see. All right, for a baseball game, 3 tickets to the Indians and 2 for the Cubs, bless you, cost $179.49. 2 tickets to the Indians and 1 for the Cubs cost $102.55. What were the average ticket prices for the 2 games? Okay, Well, we're trying to figure out how many tickets were sold for each team, and then we could figure out the price per ticket. So if we set it up like this, where we say X is equal to the number, let me see here, the number of 3 tickets to the Indians and 2 for the Cubs cost $179. So X represents the price per Indian ticket. And let's let Y represent the price per Cub ticket. Because if it gives us a total price of 179, the way that we figure this out is we figure out the total price for Indians plus the total price for Cubs equals the total price. Well, for this first scenario, it says we have 3 Indian tickets. So the amount of money you spent for Indian tickets would be 3 times the price for the Indian tickets. If Indian tickets were $50, 3 times 50 would be $150. Plus, how much money did you spend for the Cubs? Well, it says that we bought 2 Cub tickets, and that came out to $179.49. Then we have 2 tickets to the Indians and 1 for the Cubs. That cost $102.55. So we saw how to solve something like this last week when we had a system of equations. All right, so remember last week we talked about elimination and substitution. So we could either eliminate for X or Y. Does anyone have a preference? Let's eliminate for Y. If we just multiply this bottom equation by -2, we get 3x plus 2y is equal to 179.49. This would be -4x minus 2y is equal to 102.55 times 2 would be -205.10, would just give us -x is equal to this is -2561. So if you divide by -1, you get the price per Indian ticket is equal to 2561. And if that's 2561, we could go ahead and plug it in and solve for y. So 2 times 2561 plus y is equal to 102.55. 2561 times 2 comes out to 5122. And if we subtract that, we just get y is equal to 5133. Look at number 3. It says a grocer has some $4 per pound coffee and some $8 per pound coffee that she mixes to make 50 pounds of $5.60 per pound coffee. How many pounds of each should be used? So this is kind of similar if you remember when we were talking about acid and water and dilution. The easiest way to handle this was to make some kind of table. So let's make a table for this. And let's first let X represent the pounds of $4 coffee. And let's let Y represent the pounds of $8 coffee. So at least we know when we go to solve this, we'll get X is equal to the $4 and the Y is equal to the $8. The table for something like this would look like we'd have so many pounds of coffee. We'd also have the cost per pound, and then we'd get a total cost. So let's just make sure that this makes sense, because if we know that we have 2 pounds of coffee and it's $2 per pound, the total cost would be $4 for that coffee. So just to get this set up, it looks like for X, that's the number of pounds of $4 per pound coffee. So the total cost of $4 per pound coffee is just $4 times the number of pounds of coffee we have. Same thing with Y. Y represents the pounds of $8 coffee per pound. So we take 8 and multiply that by the number of pounds of $8 per pound coffee. We want to try to get 50 pounds so 50 total pounds, $5.60 per pound. And the total cost, remember what we've been doing is we've just been multiplying these. So the total cost would just be 50 times 560, which comes out to, let me see here, 50 times 560 is 280. So going back to how we handled the acid, do you guys remember doing those acid problems with the dilution and stuff? We did that before exam 1. Once we make a table like this, we could say that the total pounds of coffee, so we could say X plus Y equals 50. We have the pounds of $4 plus the pounds of $8 equals 50 total pounds. And that should equal the total cost. So we're doing total pounds and total cost. $4 per pound plus $8 per pound comes out to $280 total dollars. X plus Y equals 50. The pounds of each added together is 50. The cost per each added together is 280. It's a little bit easier once we have it set up like this. Once we have it set up, now we could go ahead and use elimination. And if we multiply this top equation by -4, we'd get -4x minus 4y is equal to -200. 4x plus 8y is equal to 280. If we add them together, we get 4y is equal to 80. And y would just come out to be 20. Again, the algebra isn't the hard part here, it's just getting organized. And if you could follow those charts, when you do the homework and you do the exam, they're all going to be very similar. If y is equal to 20, we could plug it in. X plus 20 is 50. So X would be 30. All right, so the total number of pounds of $4 coffee would be 30, and the pounds of $8 coffee would be 20. All right, let's move on to number 4. It says that a train travels 600 miles in the same time a truck travels 550 miles. So we have a distance equals rate and time problem. We have a train where distance is equal to rate times time. And we also have a truck where distance is equal to rate times time. And it's saying that the same time. So what that tells us is the time of the train has to equal the time of the truck. So this is just how we're getting started. We have to get it organized. If it's telling us the time is the same, eventually we're going to have to solve for time and solve for it. So the train travels 600 miles in the same time the truck travels 550 miles. So we're just kind of plugging in the right spot. Find the rate of each vehicle if the train's average rate is 5 miles per hour faster than that of the truck. So whatever speed of the truck, we'll just call it R. How can we say the speed of the train if it's 5 miles an hour faster than the truck speed? The truck was R. What would be 5 miles an hour more than R? R plus 5, right? Okay, good. So far we're doing a good job. In order to finish this, we know that the time is equal to the time. That's what the problem said. So if I could rearrange both of these for time and set them equal, we should be able to finish this up. So what I'm going to do is I'm just going to divide both sides by R plus 5 here. And I get the time for the train is equal to 600 divided by R plus 5. I'm going to divide by R for the truck. And I get the time for the truck is equal to 550 divided by R. The problem originally said that those times were equal. So what I'm going to do is I'm going to set this time equal to this time. The time of the train, 600 over R plus 5 is equal to the time of the truck, 550 over R. Does anyone remember how we solve a proportion? And cross multiply. So what we're going to do is we're going to do 600 times R and set that equal to 550 times R plus 5. If we solve this, we'll get the rate and then be able to answer the question. So if we just distribute this, Subtract 550R on both sides. You get 2750 is equal to 50R. And then dividing by 50. Let's say 2750 divided by 50. Get the speed is 55. So if you remember, R was the speed of the truck. And what would be the speed of the train? 60, right? Because it's 55 plus 5. You get that. All right. I have 3 more left. All right, so let's take a look at number 5. While paddleboarding, Shannon traveled 30 miles miles upstream, which is against the current. And then in 5 hours, it took her only 3 hours paddling downstream with the current back to where she started. Find her speed in still water and the rate of the current. So these are kind of like an evolution from what you had on exam 1. This is a little harder. So let's go ahead and see if we could figure this out. When you're going upstream, you're actually like going slower because the current's pushing you back. So we'll call this upstream. And this is D is equal to RT. And then we'll have another one where it's downstream. This is where we're going a little bit faster because the current's making us like go faster. So just setting it up, that's what it looks like. And it says that we're going 30 miles upstream. So that's the distance. So we're going 30 miles upstream. And it takes 5 hours. And that's against the current. So is the current making you go faster or slower? Slower. So the rate in still water, let's make S be the rate in still water. And C is going to be the current. If we're going upstream, the rate would be the rate in still water minus the current times this, the number of hours, which would just be 5. So you take your speed in still water, you're subtracting the current because it's making you go slower. Going downstream, you're going faster. So however fast you're going in still water, if you add the current to that, and it only took 3 hours to go downstream. Anyone have any questions with where those equations come from? No? So now what we could do is let's simplify, come up with a system, and then solve it. If we just distribute 5 here, we get 5s minus 5c is equal to 30. If we distribute the 3 here, we get 3s plus 3c is equal to 30. So we have another system. We have 5s minus 5c is equal to 30, and we have 3s plus 3c is equal to 30. We just have to eliminate to solve for S, which is the speed in still water, and to solve for C, which is the current. So we could just go ahead and multiply. I'm going to multiply the top by 3. I'm going to multiply the bottom by 5. We wind up getting 15S minus 15C is equal to 90. The bottom would be 15S plus 15C is equal to 90. If we add those together, we get 30S is equal to 180. Dividing by 30, we get S is equal to 60. That's the speed in still water. Oh, not 60. Not 6. Can you imagine 60 miles an hour on a paddle board? 180 divided by 30 is 6. Right? 6 miles per hour. I usually paddleboard at Monksville Reservoir. I don't know if anyone knows where that is. But some people put together some like pretty strange contraptions. There's like, you could put a motor on a paddleboard. It's just crazy. But anyway, 60 miles an hour on a paddleboard would be insane. 6 is the answer in still water. And if we know the speed of S in still water, we could plug it in and solve for C. So I'm going to plug S is 6 right here. This would just be 3 times 6 plus 3C is equal to 30. So 18 plus 3C is equal to 30. Minus 18, we get 3C would be 12. So the current would just be 4 miles an hour. The current's 4 miles an hour. The speed in still water is 6. And that's how you do a problem like that. We've seen a few of these problems with distances equal to rate and time, and that's how it works. Okay. Quinn, we okay with that? All right. Yeah, let's move on to number 6 now. Number 6, it says the sum of the measures of the angles of any triangle is 180 degrees. The middle-sized angle of a certain triangle measures 8 degrees less than twice the smallest angle. The largest angle measures 26 degrees more than the middle-sized angle. Find the measure of all the angles. Just like anything else, let's try to get organized here. We have a large, middle, and small angle. Just to try to get organized, let's put letters on them. Let's say large is X, middle is Y, and the small is Z. So it says the middle angle, that's this one. The middle angle is 8 less than twice the smallest angle. Here's the smallest one. How do we say the middle is 8 degrees less than twice the smallest angle? Close, not 8 minus 2Z. That's kind of the wrong way around. If I tell you I'm 8 inches shorter than you, all right, and if you're 70 inches tall, you don't do 8 minus 70, you do 70 minus 8, right? So if it's 8 degrees less than twice the smallest angle, we're going to do twice the smallest angle minus 8. That's how that gets set up. That's a common mistake that people do. Whenever you see less than, sometimes people put the order, a little bit differently. Okay, so let's go to the next sentence. The next sentence is the largest angle, which is this one, measures 26 degrees more than the middle-sized angle. So how can we write that? The largest is the middle angle with 26 more. So you could say y plus 26, but we already know what the middle is, right? This is the middle. So what we could do is we could say, take that middle, 2z minus 8, and add 26 to it. If we do what George suggested, that's totally fine and that's accurate. The problem would be you'd have too many variables. If we could try to keep everything with one variable, it'll just simplify everything. So now it looks like we have three angles. We have the large plus the medium plus the small, and those should add up to be 180 degrees. Because we only have one variable, we could just make one equation here. And we have 2z minus 8 plus 26 plus the medium, which was 2z minus 8, plus the small, which was just z, and that's equal to 180. And like I told you before, the algebra is the easiest part of these. The hardest is just setting it up. So when you're working through the My Math Lab homework, if you understand what's going on, just keep hitting do a similar problem. Keep doing that until you get it, and then I would move on to the next type of problem. So let's go ahead and solve this. We'll combine like terms. So we have 2z plus 2z plus 1z is 5z. Negative 8 plus 26 is 18. 18 minus 8 is 10. If we subtract 10 on both sides, we get 5z is equal to 170. So z would just be, if we divide by 5, 170 divided by 5 is 34. That's the smallest angle. So this would be the smallest. Y is the middle. And in order to do that, it would be 2 times z minus 8. 2 times 34 is 68, minus 8 is 60 degrees for the middle. And then the largest one would just be 2 times the smallest, minus 8 plus 26. 2 times 34 is 68, minus 8 is 60, 60 plus 26 is 86. And if you add all those angles together, you'd get 180 degrees. All right, so I have one more problem left for us tonight. A department store has 3 kinds of perfume. We have red, white, and blue. There are 10 more bottles of red than of white and 3 fewer bottles of blue than of white. Each bottle of red costs $8, white costs $15, blue costs $32. The total value of all perfumes is $5.89. How many bottles of each are there? So because we are quite a bit early here, and this is the last problem, let me give you maybe 2 or 3 minutes to try to set it up on your own. Come up with your variables. When you go to come up with an equation, remember the total value is equal to the price times the number. So the value for the white plus the value for the red plus the value for the blue is equal to 589. So you have to come up with your own variables. and see if you come up with an equation that makes sense. Just so we're all on the same page, let's let red be X, Y could be white, red, white, and blue. And these could represent bottles of each. All right, so take a minute, see if you could figure that out. I'll just give you a couple minutes. We'll still get out early, but I want to see if you could put this together here. All right, so let's see. According to this, we have 3 kinds of perfume. There are 10 more bottles of red than of white. So however many number bottles of white there are, there's 10 more red ones. So I would say X is equal to Y plus 10. Anyone get that on their own? All right, so that's good. Let's go to the next one. There are 3 fewer bottles of blue than of white. So how do we say that? Y minus 3. Each bottle of red costs $8, white costs 15, and blue costs 32. When you add them together, you get 589. So let's come up with a value. So the value for the white would be $15 times the number of white, so 15Y. If it's $15 per bottle and you have 2 bottles, it's $30 total. The value for red was $8 times the number of red, Y plus 10. And then the value of blue is $32 times Y minus 3, and that's equal to 589. At this point, we can multiply everything out. We get 15Y plus 8Y plus 80 plus 32Y minus 96 is equal to 589. And we're off to the races with just simplifying here. So 15 plus 8 plus 32 gives us 55Y. 80 minus 96 is negative 16. If we add 16 on both sides, 55Y is 589, plus 16 is 605. Dividing by the 55. 605 divided by 55 means we have 11 bottles of white. If we have 11 bottles of white, 11 minus 3 would be 8 bottles of blue. And how many bottles of red? 21, right?